Alright, in this video we're going to be learning how to solve trigonometric equations. And the idea behind solving trigonometric equations is that we want to try and find what given angle would allow us to cosine it and give us some output, some answer. And because we have a unit circle defining our parameters, we really have an endless number of solutions. And so what we need is a domain. A domain sets up how many times or how much of our unit circle we're actually thinking about. Because if we didn't have a domain, we could go around our unit circle for, unlimited amounts of times. And so we would have an endless number of solutions. So let's go ahead and solve this. I'm going to draw my unit circle first to figure out a couple of things. Namely, whereabouts on our unit circle are we? Like what quadrants? Right, so if I have a look at this question, the cosine of something, some angle, right? We're used to theta, but we're given x here. The cosine of some angle will give us 1 on root 2. Now I can immediately go to my table and identify that the cosine, right, let's zoom in here. The cosine of what angle gives me 1 on root 2? 45 degrees. But I'm not going to say 45 degrees. I'm going to work in radians. Pi on 4 radians, because our parameters were given in terms of pi. So pi on 4 or 45 degrees, but let's stick with pi on 4. So let's go ahead and draw an angle of pi on 4, and I know it's roughly there, and we'll write that as pi on 4. Now we know that if we take the cosine of that angle, right, the cosine of the angle is how far along the x-axis we had to go. Not how high up, right? But just how far across did we have to go. And we know that it was 1 on root 2, right? Because the cosine of 45, or the cosine of pi on 4, that's how far across the x-axis we need to go. I'm going to highlight that. So we have to go across 1 on root 2, right? We have to go across 1 on root 2 units across to get to that. But my question becomes now, right, we have to go across 1 on root 2 units to get to that coordinate. Is there another point along my entire unit circle, right, let's start again from 0. Is there another point along my unit circle where I can also go across 1 on root 2 units? I hope you can see it's roughly here. Because if I take that angle, right, this angle here, I will be 1 on root 2 units across. So I'm going to draw that angle, roughly. And so, as you can see, I've gone around all the way. And so I hope you can also see that if we zoom in, because I have gone around, because I've also gone across 1 on root 2 units, well, this angle must also be, just the size of this angle, must also be pi on 4 in size, right? So this angle here, just the size, not the direction, but the size must be pi on 4. Now, if we include the direction, because if we look at our domain, we have to go between negative pi and positive pi. The negative means we're going not in the positive direction, but the negative direction. So let's go between negative pi and pi. Ready? I'll show you. We're looking for solutions between negative pi and positive pi. I'll do that in one go. Ready? Between negative pi and positive pi. Can you see? I am including the entire circle, but it's between negative pi and positive pi. So we don't go around like this to achieve or to get to our point here. We have to go this way because we're going to negative pi. So our angle here is negative pi on 4 and positive pi on 4. So negative pi on 4, positive pi on 4. They are our two solutions for this question here. So the cosine of x, sorry. Let's write that again. X is equal to, now let's think about it, pi on 4, or, well, it's really not or, it's and, x equals negative pi on 4. They are our two solutions. All right. Let's go to our next question now. We're solving 3 lots, or 3 multiplied by sine x plus 1 equals 0. In between 0 and 2 pi. Now that's a little bit easier. It's just going around clockwise, anti-clockwise from 0 all the way around to 2 pi, the full circle. Let's go ahead and draw a unit circle again. Yeah, I might just adjust this just a little bit. I might bring this up slightly. All right, I'm happy with that. Let's go ahead and just shift it across for now. Okay, now remember, when we're solving, we're trying to find out what angle we must have such that we multiply 3 by the sine of that angle, and we add 1 to it, and we get 0. Well, that's a bit complicated. So what we're going to do is we're going to try and isolate the sine of x first by removing 3 and removing 1. Well, how do we do that? We just use our simple algebraic tools, our rearranging tools, and we write the three lots of sine x. If we take 1 from both sides, we'll get equals negative 1. So essentially, this comes over here. And there are operation reverses. Again, I can divide both sides by 3. Right? Divide both sides by 3, cancelling out these 3's, and I get the sine of x equals negative 1/3. So if I go ahead and think about this, the sine, right, is how far up, how far down I have to go. And if I take the sine of some angle, whatever angle this may be, I get negative 1/3, meaning that I have to go down to negative 1/3. Now that's probably too far, isn't it? Let's zoom in here. It's roughly, let's say there, right? And what 2 points on my unit circle allow me to go all the way down to 1/3 or negative 1/3? And they're roughly, you ready? Roughly this point and roughly this point here. Okay, they're the two the possible solutions. So I'm going to draw them. Did we agree roughly there? Roughly? Yep, and they're our two possible solutions. Okay, so let's go ahead and then we'll go, well, the sine of what angle gives us negative 1/3? We just go to our table like we did in our previous question. Right, let's go over here. The sine of what angle gives us negative 1/3? All right. The sine of what angle gives us negative 1/3? Oh, we don't have the sine of a particular angle that gives us negative 1/3. We don't have enough values here. We don't have enough angles. So we can't actually use our table here. So we need a different strategy. And the strategy here is that we can go to our calculator and find out what that angle must be. And so that angle we determine by finding the inverse sine, right? And it's written like this. It looks like sine to the power of negative 1 of our answer here. But we are not saying sine to the power of negative 1. It's the inverse sine. The inverse sine. We'll use our calculator in a second. I don't have the scientific on the screen, but I'll use Desmos calculator in a moment. Okay, let's think about this. We are interested in finding out, ready, from here, or from here, this angle in our third quadrant and this angle in our fourth quadrant. Now, in our third quadrant, right, this quadrant here, our angle would be equal to, ready, 180 plus our reference angle, but we don't know our reference angle, don't we? Well, we can find out what this angle is. Let's do it. So the sine of -1, or the inverse sine, will be equal to 1/3. Now, why did I not put the negative sign here? It's because if we put negative here, we're really only interested in finding out how far we have to go down to get to that coordinate, right? Because we're finding out the sine of that angle, the sine. But we're not really interested in finding out, we already know that we're going down because we're in the third quadrant. I just want to know the size of that angle there. What's the size of that? And so we're just going to use the positive value of 1/3, right? We just want to know how big it is. We already know it's going down, so we're just not going to use that negative value. So let's go ahead and go to Safari. And we've got Desmos here. Let's find the inverse sine function. Where is it? There it is. The inverse sine of 1/3. Delete that. That gives us 0.3398 radians, okay? Because we're working in radians here. So let's go ahead and write that. So that'll give us 0.3398 radians. Okay. All right. What we can do from here is, because we use the positive value, that allows us to then say, well, this here is 0.3398 radians, right? I'm going to write it in really thin font here. That's 0.3398. And then here is also, right, that's the same thing. So 0.3398. All right, all we need to do now is consider, let's get rid of this, is consider that to get this angle here, it's, ready, pi radians plus that extra 0.3398. And to get this angle, it's, ready, 2 pi take away that 0.3398. All right, so they are our two possible solutions. So we'll write them below. X will equal pi, add 0.3398, and x will equal 2 pi, take away 0.3398. So x will equal, right, let's use our Safari again. Here we go. So I've got the answer there sitting there for us to use. So let's go ahead and do pi. Oh, by the way, it's really important to recognize that we're in radians. Can you see on Desmos here, I'm flipping through radians and degrees. We need to be on radians because we're working in radians. So even on your scientific calculator, right, shift mode, and then you have to click the number relevant for radians. So let's go ahead and then write. We're looking for the pi symbol, pi. We're going to add that to our answer, and that'll get us 3.481 radians. And x will equal, so let's go ahead and do function 2. Oh, let's get rid of this. We'll go ahead and go 2 pi. We'll just edit this one. Take away. So 2 pi take away our original answer, which will give us our angle in the fourth quadrant. And that's 5.943. 5.943 radians. And so they are our two solutions for that question right there.